Right, as I am all that is standing between you and the panel, I'll be quick. So, forensic watermarking, what is it? Well, forensic watermarking allows us to determine who leaked that video. Why do we do it? Well, we use it to combat revenue leakage in video services models. Attacking the digital outputs on a device is now trivial. If I take a splitter and I put it on an HDMI output, yeah, I can get your digital video and I can re-encode it. Early release windows. We want to do early release content. We want to bring the content windows in. And so we need to protect our video when it's in the output domain. And it's part of Movie Lab's enhanced content protection. The idea of forensic watermarking is when that video leaves your trusted device or untrusted device to the display device, it is individually marked for a customer. So, an approach to watermarking. Now, in this scenario, we'll assume we're going to create two marks, an A mark and a B mark. And in theory, there could be N marks. But let's assume we have a 0 and a 1. So, we take our mezzanine content in on the left-hand side, and we run it for a preprocessor. The preprocessor is going to pick up the frames, and it's going to look for points it can mark. And then it's going to apply a 0 mark in one and a 1 mark in another copy. So I now have two output files, a 0 copy and a 1 copy. I take those files, and I run them through my transcoder, and I produce my ABR output. Now, I now have a set of A segments and a set of B segments. And by combining those segments in a different order, I can actually build a mark. So, let's just, before we go any further, quickly look at a demo of what this looks like. So, okay. So, here's a little demo web page. And if I type in a random number here and hit change ID, what you can see is the player is going to go away. And it's taken that number I've put in that box, 2, 3, 4, and it's created a bit stream of it, 11101101. And if I was to put a different number in, we would see a different bit stream, a different set of A and B segments. Now here, clearly, we've got a visible watermark. And in reality, you would never do that because you want to obfuscate from the customer. You don't want a giant 1 in the middle of the screen. All right, moving onwards. So how do we do this in Dash? Well, there's a number of ways we can do this in Dash. We can use the segment list tag. Now, we've all been warned about the segment list tag earlier in the day. We were told not to do it. It creates manifests that look like HLS. And not only that, multiply that by the number of representations you've got, and the manifest soon becomes really large. We can do server-side selection of segments. We'll talk about that. We can change the Dash spec, and we can add a template in, an additional template in. And we'll talk a little about that. And the final method is we can do it in Silicon. Why do it in Silicon? Well, the advantage to do it in Silicon is we don't have to change anything. The other advantage is we can apply it to broadcast. So satellite feeds, terrestrial feeds, can all now be watermarked. We are seeing that today in things like the Broadcom. Broadcom 7271S supports watermarking inside the silicon. You initialize it correctly, you tell it what bit pattern you want, and under the covers, it can do that. It actually has some neat other uses as well. You can use it for revenue detection of, say, sporting events. You can put a mark that's flashed up in for like a single frame, capture that mark, and then shut that person down. Don't do it in Colombia during the World Cup final. You will die. All right, segment list tag. Makes it look a lot like HLS, but it works today. Problem with this is really high overhead. You have to list every representation out, segment by segment. And it doesn't allow caching of the manifest. Server side. What we could do, I guess, is we could call every segment segment A, segment 2, segment 3, segment 4, segment 5. We could have it so when the request comes into the CDN, that I pick either A or B and return the appropriate segment. However, the problem with this is it gets blown up by transparent caches. So if I have a transparent cache and I call everything file sequence 1, when it hits that transparent cache, guess what happens? That 1 gets cached, so the next client that gets it gets a 1, even if it should have a 0. It requires modifications to the content delivery network as well. It's really not a happy thing. Now let's talk about the final way we looked at doing this. What if we were to take the Dash manifest and add another tag in that had a list of A's and B's? Think about the way the Dash representation works today. Today I say I start a number, say let's start 0, and it goes file sequence 0, 1, 2, 3. What if I had an additional tag that I iterated across? A, B, A, B, A, B inside the thing. And then I let my client-side thing pick A, B, A, B, and add that into the file sequence with the file request. So now I see file sequence 0A or file sequence 0B, depending on what's in. I move to the next element and I get file sequence 1A or file sequence 1B. It would work. Nice thing about it is very minimal overhead. It's just an extra tag inside the representation. It needs no changes really server-side other than the fact that I have to generate a personalized manifest. And yes, I appreciate that I'm about to get the same question that the ad folks are about to get. How do you scale that? Yes, it's a problem. It does require client-side changes because we have to know to iterate across this list. And sadly, the last part is sadly the most important. Unless we're validating that tag on the server side, if somebody comes in and manipulates or proxies the manifest and changes AB, AB in your sequence to BB, BB, you're going after the wrong person. Done. I said I would be quick. Any questions? Yes, sir. Alex at the back. I figured I wasn't going to get away with this, was I? Mr. Rosen, sorry.
It's great. Let's put that addition into Dash right away. And then, once we accomplish that, why not go marching back to the authors of MPEG-Part 12 sample variant and have them add it to their standards so that it's cryptographically enforced, which would also spoil those who would fake the manifests.
And I think that comes back to the server-side manifest validation. One option is that, yes, you could put it in and cryptographically sign it, but what's going to verify the signature client-side? I think realistically, you've got to validate the signature server-side. Unless, of course, you also apply it with DRM as well.
But again, sample variant, which isn't used in streaming, and
Yep.
is only done in silicon, and is really only popular in Fox. I take that part back. But at least for that published standard, the keys rotate.
Yes.
Even if someone hacks the client, it still has to do the switches.
As-
Is that a good idea?
It's a good idea. It would require multiple keys to be handed out, and effectively, you may even have multiple key IDs, yes. But I see that, yes.
Well, so hurry up and pass one stage so you can make a second one or change it. Yeah?
Agreed.
Okay.
Anyone else? Yes, sir.
Yes, so a lot of the content is offered with the on-demand protocol. So I know Netflix uses its the on-demand protocol. Basically, how would this work then? I don't think that applies because you use byte rate request into the file caching and so on.
That would, yes, that's, It does require effectively a fragmented approach to the file and for it to be split up into segments. What you're going to end up in that scenario is either to have the same segments have effectively got the same length, which would be inefficient, which then would mean that, say, the A segment and the B segment are somehow manipulated to be the same byte length, which would effectively give you the same result. I guess what you could also look at is customization of the init and the CIDIX to be done on a per stream basis. Effectively take the A and B CIDIXs, create the appropriate response to the client. And so therefore, segment file sequence 2 CIDIX is correct. So when I get the byte range request, effectively I know that, or the byte range request is right for the second segment. So you could, I guess, you would actually, I guess, in that scenario, have to create a custom init segment on a per stream basis. Does that sort of answer your question?
I need to think it through, but I believe it's, I'm not sure. I need to think it through.
Yeah.
I think it's complex. And also, I need to check all of this method as well. It was proposed in the last FB meeting. Ali proposed it so that we were not clear about all the details. I think what was missing was the server-side authentication, which is absolutely irrelevant otherwise.
Yes. No, with this mechanism, without the server-side validation, I proxy the MPD request and I could manipulate it. I absolutely agree with you. Anyone else? Good. You're done.